So 7.2, part 2, we're going to look at radian angles. And we're going to look at really three specific things. How do we draw them? So we're going to go ahead and draw them. That won't really be the first thing we do, but it's the first thing that's on your assignment, so that's why I put it first. We're going to convert from degrees to radians. So we're going to show you how to convert from degrees to radians and from radians to degrees. This is just all kind of what we're going to do today. And then the third part about it is we're going to talk, just like yesterday, we're going to talk about coterminal. And how we go about converting things if they're coterminal angles that are in radian measures. So I'm going to start out with what is a radian measure, what is a radian angle, and that type of thing, and we'll kind of build it from there. So yesterday we talked about this coordinate plane stuff, and we said that each of these little sections was 90 degrees. And then each of the ways around, then the whole way around a circle was 360 degrees. And then one of the things we did was we went ahead and said, okay, let's draw a 120 degree angle. And then we created what we called the terminal side. So this was somewhere in the 120 degree range. Okay. Well, there's another way that you can calculate things around what we call kind of this unit circle. So instead of being coordinates or degrees, we can do what's called a unit circle. So if we have a circle that's around kind of our coordinate plane, if we look at this circle itself, and I'm going to go ahead and draw all of this stuff back in here, we can say that that's 120 degrees, but we can also convert this to what we call radian measures. Radian measures are essentially dealing with the circumference of the circle. And back in geometry, you learned how to find the circumference of a circle. And what you found out, if you found the circumference of a circle, was you learned that the circumference of a circle is 2 pi times the radius. And the circumference is that distance around. Well, with this unit circle has a radius of 1. So if I have something that has a radius of 1, I can put a 1 in for that. And then if I have a radius of 1, this has a circumference of 2 pi. So the whole distance around a circle is going to be 2 pi radians. So instead of 360, we could also say that that's 2 pi radians. And again, that's talking about the circumference around that unit circle. So we could put a 2 pi there. Not only could we put a 2 pi there, but then we could divide this into different what we call radian measures by kind of breaking it up. If I go to up here, in radian measures, 90 degrees is going to be the same thing as pi over 2. So we say it's 90 degrees or pi over 2 radians. 180 degrees is pi radians or 180 degrees. And 270 degrees is the same thing as 3 pi over 2 radians. And kind of all of these little spots within here, we could kind of divide up as well and give them radian measures as well. But in order to do that, I mean, is there a memorization that you could do? Yes, if you're in honors pre-calc or something at that level, you actually kind of memorize kind of this unit circle and figure out where each of these points are, and you do a bunch of different things with this. Our main goal in here is just to kind of get that basic idea of what a radian is, and to be able to convert it. So if I ask you to draw a 120-degree angle, like we did yesterday, that's pretty simple to do. But if I ask you to draw something like 5 pi over 6, you would have no idea where that's going to be. You could go 5 divided by 6 and say, well, it's less than 1. So since it's less than 1 pi, it's got to go over here somewhere. But exactly where does it go? It's hard to say. So one of the first things that we need to be able to do is we need to be able to convert. And we're going to come back to this. No, we'll just kind of stay on this slideshow. But so the first thing we need to be able to do is we need to be able to convert from radians to degrees. So we are going to convert, actually we're going to go the other way, degrees to radians. So we're going to start by going degrees to radians, because we know what degrees is. So if I know something is 120 degrees, and I want to know how many radians it is, we need to have a conversion for that. When you convert from radians to degrees, there's a simple formula. You're going to take your degree, which I'm going to use the 120 degree that we have up there. And you're going to multiply that by pi over 180. So this is essentially your degree times pi over 180. This is how you convert from degrees to radians. We're going to leave it in terms of pi. So if I multiply this out, this is 120 pi, if I could put 120 in there. This is 120 pi over 180. Now I've got 120 and 180. I want to be able to reduce that to this. I want to be able to reduce the fraction, and 60 goes into both of those. So 60 goes into 120 twice. It goes to 180 3 times. So 120 degrees is the same thing as 2 pi over 3. And we're going to leave it like that. You're not going to multiply by pi and do all that stuff. This is simply your answer when you're converting from degrees to radians. And this is the formula that you use for converting. It's your degree times pi divided by 180. So now if I go back up to this drawing, and I don't lose it on the screen up there like I just did. Wi-Fi has been a pain in the butt still today. That 120 degrees, not only is it 120 degrees, but it's equivalent to, what do we say?
2 over 3.
2 pi over 3. It's equivalent to 2 pi, nice 2. It's equivalent to 2 pi over 3 radians. Those have the same ending point if you're going to graph them. Okay? So let's look at a couple more examples of that. Move on. So let's say that we have something that is negative 30 degrees. And we want to convert this from degrees to radians. So we've got it in degrees. So we said going from degrees to radians, our formula was the degree times pi over 180. So if I have 30 degrees, to convert that to radians, did I have 30 or negative 30? Negative 30? I'm going to take negative 30 times pi over 180. And now reduce it. 30 goes into itself once, so that's negative pi over 6. So negative pi over 6 radians is the same thing as 30 degrees.
So you just divide by 180.
All I'm doing is taking my fraction now, negative 30 over 180, and reducing the fraction. So you could cross out the zeros.
So do you always use the 180?
Yes, it's always over 180. Yep. So your conversion is always degrees times pi over 180. Negative 1/6. Okay, so let's say that we have negative 610 degrees. And we want to convert that to radians. We could draw that. We know how to draw that. We did that yesterday. But we want to convert it to radians. So it's my degree, negative 610 pi over 180. Now we have to reduce it. So we're just looking at the negative 610 over 180. If you've got this calculator, negative 610, hit the ABC button, 180. So negative 610, ABC 180, hit equals. And you're going to get, and we don't want it like this, but in your calculator you'll get something that looks like this. We don't want that. So to get it, it's an improper, that's a mixed number. We want it as an improper fraction. Hit second in that ABC button, and it will convert it. So this is negative 61 pi over 18. And that's your solution. Okay, and you leave it in terms of pi. Don't multiply it out. Anytime you're going from degrees to radians, your answer always has to be in radians, and your radian answer is always going to have pi.
So basically, it's just like, think about it. The pi just keeps right there. You don't even have to.
Don't even deal with it. Yeah, it just stays there. Just deal with the numbers as far as reducing. Yep. Okay, go ahead and give this one a try, and we'll move on. So 160 degrees. Go ahead and change that to radians. Eight pi over 9. Easy enough to change it from degrees to radians. Okay, the ultimate goal really for this is to be able to graph them. If I ask you to graph a 610 degree angle, you can do that. If I ask you to graph a 160 degree angle, you could do that. What happens if I ask you to graph, let's say, negative pi over 4? Do you know how to graph negative pi over 4? Well, no. I mean, do you know where negative pi over 4 is at? Probably not. So we can convert it. So just like you can convert from degrees to radians, you can convert from radians to degrees. So to go from radians to degrees, you're going to take your radians, whatever that is, times 180 over pi. Whatever your radians is, times 180 over pi. So in this case, if we've got negative pi over 4, that's our radians. We're going to multiply that by 180 over pi to change it to degrees, so we know where to put it on the coordinate plane. Well, the pi's cancel each other out, which is good. So we end up with negative 180 over 4. Multiplying fractions is no problem. Take the top times the top, and the bottom times the bottom. And then if you take 180 and divide it by 4, negative 180 and divide it by 4, you get a negative 45 degree angle. Now if I ask you to draw a negative 45 degree angle, you know how to do that. But where you graph a pi over negative pi over 4, I mean, who knows? Okay, lots of people do know, just need to make sure you know. Okay. So let's do the same thing. Let's go ahead and graph 5 pi over 4. So step one, if you're asked to graph this, is to change it to degrees. So to change it to degrees, it's 5 pi over 4 times 180 over pi. Pi's cancel out. And the easy way is just go 5 times 180 divided by
So it's 900.
4. So that would be 900 divided by 4, which is 225. So if you have to graph a 225 degree angle, there's 90, there's 180. If I go to the next one, it's 270, which is too far. So this is the graph of 5 pi over 4, which is equivalent to 225 degree angle. Let's go with, give this one a shot. Go ahead and graph a negative 47 pi over 36. And go ahead and do that one on your own. So convert it first. Shoot. So you should have got negative 235. Did everybody get that?
I'm stuck at the 8,900, I think.
Divide that by 36.
Oh, okay.
So then negative 235. You start at this here, 90. And this is from yesterday again. So there's negative 235, somewhere right in there, and you're done. Okay. So can you convert from degrees to radians and radians to degrees? Can you graph radians? First part of your assignment today is going to have you graph radians. Just do this first. Change it to degrees. Once you change it to degrees, then go ahead and graph it after that. The next 5 or 6 or next questions are going to ask you to convert measures to radians and then convert to degrees. And then the last part of today is coterminal angles and taking radians and finding the coterminal angles for radians. So let's say that we have 7 pi over 4. And the directions here are to find a positive and negative coterminal angle. So we did this yesterday, and when we talked about this yesterday, what we said we did was we had that degree measured. And to find positive and negative coterminal angles, you added 360 and you subtracted 360, and if it wasn't either way, you did it again. Well, when we're talking about radians, we certainly could change this to degrees and then subtract 360, figure out what that is, and then convert it back to radians because I want the answers in radians. And then subtract 360 and then convert that. You could certainly do that. That's one way to do it. If you want to do it that way, 100% understand. There's nothing wrong with that. You get the same answer. The other way is to think about it in radians. And when we talked about radians on the first slide, what was it completely around a circle? What was it? The whole thing around the circle in that first slide. Instead of 360 degrees, we said it was what pi? 2 pi. So instead of adding and subtracting 360, we could add 2 pi to this. And we could subtract 2 pi from this, because that's the distance around a circle. I mean, as far as radians go. Okay, we say it's 2 pi instead of 360 degrees. Well, now we've got to do this. Take the pi's away, and then you'll put them at the end. So essentially, we're going 7/4 plus 2. So you break out your trusty dusty calculator, and you use the ABC button because we all like fractions so much. So 7 ABC4 plus 2. And when you do that on your trusty dusty calculator, it's going to tell you it's 3 3/4. Well, we don't like that. So hit second ABC, and it will tell you that that's the same thing as 15/4. Now we're just going to put the pi back in there because we want to know how many radians it is. We just took the pi away there just to not confuse ourselves.
Wait, on the calculator, it's ABC and then ABC squared.
No, just 7 ABC4 plus 2. I'll come back and show you how to do it.
What's the ABC button if we have a...
So it's the one right underneath the probability.
I don't have...
Yeah, I'll come back. We'll find it on that one in a minute. Okay? Let me go through this second example, and then I'll come back and find it with you, okay? So for the second one, then, it's 7/4 minus 2. So 7 ABC4 minus 2. And that one just gives you the answer. -1/4. And just put a pi with it. And that's your solution. Okay? So I told myself I was going to be done with you guys by 40. Eesh, I didn't quite make it. So I'm going to be done. There's a little bit more we have to talk about, so 17 and 18. But I want you to give you adequate time to get this done before you leave today. Those are the things that you have to do today.